Hey guys, Madhav here. I'm going to show you how to use Microsoft's Makefile Tools extension in VS Code to help you debug C and C++ files much faster than normal. What you're going to need to start is you're going to need to have used GCC to compile C projects or C++ projects before. I hope you've at least heard of a Makefile, but don't worry if you're not familiar with the syntax, we're going to go through it. Now to get started, you'll need to have VS Code installed and you'll need to have certain extensions. First, if you search C and C++, get the IntelliSense and debugging extension, because obviously we're debugging. You might also want to get the themes extension. Also, you'll obviously need the Makefile extension that is right over here. It's published by Microsoft, you can't miss it. Now, assuming you have that set up, I just want to show you this project that I was recently working on as a motivating example for why we need to do this kind of thing. Don't worry, we're not going to look at all this complexity. I'm going to jump over to a simpler project after. So, recent project I was working on, it was a multi-threaded image download application. As you can see, I have an external header file for image processing functions, and that itself depends on other header files for other utilities, like a compression utility, for example. Now, all of these dependencies between what I want, just an end executable that can do the image processing, and all of these different sources, all of these different C files, makes it complicated for me to use command line tools like, say, GDB. I need to make sure that I build the right executable every single time, linking together all the code from different places, which can get complicated if I'm just typing in a command in the command line every single time. So that's why we're going to be jumping over to the Makefile Tools extension to automate all of that for us. To show you how it works, I'm going to move over to the simpler project. Now here, I have a very simple script. It just reads two numbers, either from being sent them in the command line arguments or by asking the user to enter them. And after that, it just finds the square difference of these numbers with the function that I defined in this other file. You can take a second and look in the description if you want to get this code, and I'll have published it for you so that you can follow along. Now, as you can see, in the past I was using, let's say, GDB to run, my debugging. But the problem is this final executable that I want, it depends on the source code and also some code in a header file. So I need to make sure to type in the right GCC command, for example, this, every single time that I want to debug something. Now that can get inconvenient with all these different arguments and whatnot. So this is where makefiles come in. Now, take a deep breath. The syntax will look unfamiliar if you haven't seen a makefile before, but I'm going to go through it step by step. So the purpose of a makefile is to be able to split up commands like this compilation command into different parts and reuse those different parts every single time, automatically figuring out based on what I code, what needs to change in order to go back to me doing the debugging work. So first off, we need to split the commands we need into different sections by using variables. So just like we can, go through variables in a C program, we can have variables in a Makefile program. So for example, here I am using the compiler that I want as a variable, and over here I'm using some compilation flags like the ones you see here to give me better warnings. There are also some variables that I have defined related to the places that I have actual C code, logical code, some intermediate compiled files I want to create, and also the end thing that I'd like, which is, let's say, main or main.exe, the executable script that I'd like to debug. So now the key part, how do we actually use these variables? Before I show you some messy syntax, I'm just going to go over some key idea with words. So the general idea is to specify the intermediate requirements we need before we get to the end goal. So if the end goal is the final executable, we have some intermediate requirements like some object files, some compiled code that needs to be linked together. So what we're going to do in the syntax that follows is generally just I need some, end target, and I'm going to specify the dependencies of that end target onto other files. So let's say file A, it depends on file B, and file B depends on file C and D. Well, if I'm trying to get to file A, I need to keep track of all these other dependencies. So let's say I'm trying to get to A, but file C has changed. Well, file C is a dependency of file B, so I need to recreate file B. And once I have done so, I can then use the new file B to recreate file A, and now I'll have the updated version of file A. Take a second to read this over if that was a little bit fast. We're now going to look into the actual syntax of the Makefile so that we can enable this kind of automatic dependency tracking. So the first thing that we're going to do is we're going to create the end file, so main.exe. We're going to define that this is the target we want, and it's reliant on all of these object files, intermediate files, that are needed to be linked together in order to produce the executable. Now, once we've specified, okay, here is the final dependency, and here are all of the object files. Keep in mind dollar and then this parenthesis, it just takes what we've defined in this variable and substitutes it here. Now that we've done that, what we need to do is we need to specify different commands that we can run in order to actually get the final executable we want. So $cc, it takes what we've defined here, GCC. The C flags come after the GCC command, just like they do in our command line. So we take all these flags and send them in here. And then we can define our output. $A is the name of the output, and $caret, those are all of the dependencies that are also going to be outputs in the process of running this command. Now, hopefully that was one example of how you can get from object files to the main.exe executable that we're looking for. But the question that arises is, how do we get those object files? Well, what we can do is we can make another such rule, which now says the target is the object file and is dependent on the C files. Keep in mind, % is a wildcard, so main.c, it will depend, main.o, it will depend on main.c, and calculations.o will depend on calculations.c. So this is just a wildcard that matches anything. Again, we follow a similar syntax. $less than in this case is just the first dependency because we do not have a list of multiple dependencies like last time. So hopefully you can see how that relates to the logic I talked about earlier, specifying the dependencies between the end goal, which is the executable files, to the intermediate files, which are the object files, and then linking those object files themselves to the C files. So I can go and code away in calculations.c, and the Makefile will take care of turning those into object files and the object files into C file, the executable files, without me having to change anything. Now, you might think, okay, sounds good in theory. How do I actually use it? How do I use a Makefile? Well, what we do is we generally use commands called make all, which, go through all of the logic and change everything that needs to be changed, or make clean to clean up all of the logic and, delete anything we don't need anymore. These aren't just magic commands, you actually define them. So generally, when you do make and then some word, it means you're going to have a file name here that you're wanting to build. For example, make main.exe. However, we can override that default behavior to actually create commands called make all and make clean. So make all, it just means, we're going to have, just like we have different files, we're going to have a command called all, and it's going to depend on the targets, and the target is of course main.exe. So when we run make all, it's going to try and run whatever code is needed to produce main.exe. Make clean, there are no targets in this case. It's always going to run when we type in make clean, and it's just going to remove all of the object files and the targets. Now, just like I said earlier, these aren't actually files. These are, things we're hijacking to create commands. So we put in a special command called .phony, which just specifies to the makefile, okay, these aren't actually files, we're just hijacking this syntax to create commands. So that's your intro to makefiles. Hopefully that wasn't too bad. I'm going to show you the syntax now. So you can see I have a previous main.exe from my previous manual compilation that I did with GCC. We're going to get rid of that by running make clean, which will delete that as you just saw. And now we can do make all to go through all of the different commands that you can see here. So GCC, put in all the flags, and then compile main.c into main.o, and then GCC, compile calculations.c into calculations.o. That's happening because of this rule that we have. And then we take all of the object files and we link them together to produce main.exe. And that's because of this rule over here. So you can see we didn't have to type all that. Make figured out what needed to be run in which order in order to make that functionality happen. And now we have main.exe. I will show you again. I can run it and enter two numbers and I get, what I got before. So now that we have covered all of those basics, I'm going to run make clean again to clean up the workspace. How do we actually use this extension in order to debug? Well, usually you'd go to the debug menu, but because we have the Makefile Tools extension, we have this special icon over here, which is the Makefile debugging. So here we can set a bunch of options in order to make the debugger detect, here's the Makefile in our home directory in this case, and that's the default. So, whatever workspace we have open is just in that root folder. And then run all the commands we need in order to do building, that's producing the executable, and launching the target, which is launching it for debugging with GDB. So here's what we're going to do first. You'll see when you hover over this, it's going to automatically detect your makefile. If you configure your project like mine, there's a GitHub repo in the description again if you want to try this. It's going to detect that it's just in the the root folder that we have here, as you can see in the icon that just popped up. It also detects that we have make installed, so that's also good. Now we're going to configure it to build the files the way we want. So to configure it, we just click this edit icon, and what is the default build target we want? Well, we just want to run make all so that it can produce the output we want. So now that we've configured that, I can use this build button, click it, and you can see it went through, and with the GUI, now I just built everything I wanted. We can go back and configure something for launching as well. So if we want to launch, it means which function do we want to debug? Well, it's the main function of main.exe, and as you can see, it was creating a settings.json file, which goes in VS Code, which is where all of this information gets saved on, what VS Code should remember in terms of what you want to debug, what you want to launch, what you want to build, etc. So now that we've saved that, let's try this again, and hopefully we should have what we need in settings.json now. So what I'm going to do now is I'm just going to go and show you how the debugging works. So I will just click on this debug button now that I've configured the launch the way I want it. And I will just press here. It's going to run make all, and then it's going to open the debugger. So this is GDB here. You can hop over to the debug console. And I'm just going to open up main.c, which is the main file that it's going to be debugging, because that's what we specified in the settings here. Now here we have a step-by-step debugger, just like you can do in the command line. So I can, let's say, set a breakpoint over here, and that's just declaring a number, so that's not actually a command that can be executed, so it jumps to the next nearest breakpoint, which is over here. And I'm going to restart to get the code to automatically stop at the right breakpoint. And now we have the fun parts, or the useful parts, which is we have all of the variables here that we can inspect and every line of execution. So we can see here A we have and B we have declared them, but they're just random numbers right now. We haven't set them to anything. We can also create watch points here. So for example, we can put in any C++ code here, and it'll try and show us what we're trying to get. So for example, a plus 1, it will show us it's 1 greater than a. Oftentimes I use this to dereference arrays or pointers or whatever, so that I can try and debug stuff. So for example, we have argv as an array, and what the first value of that array should be is the command that we called to run this program while debugging. And if you zoom in, it's going to actually show the first character of that string. So that's what argv is storing right now. Okay, so with that out of the way, what can we do here? So let's say, is argc 3? I'm not sure. Let's see. It's 1 because, we just, that's the way we called our program. We didn't pass in any arguments. So if we run this step over button, it's going to jump to the next line of code that should execute, which is, this block wasn't available. So now this block should run. If I want, I can step into the printf function and see what's in there. So you'll see my stack got updated. This is a function that is from, the standard library. It's not one of my functions. So some kind of bug is happening where I can't see the source code there. So I'm going to jump back out and go back into my own file, and you can see the call stack updated accordingly. And now I can continue debugging. So if I go to the terminal and just jump through stuff, it's going to say enter two numbers, and it's now waiting for me to enter the two numbers I need. So I can put in, let's say, 5 and 2, and now we're back into the execution of the code. Here I can actually jump into the function because, this is a function I wrote in my file. So let's jump in, and you can see this is what it's going to return. You can see in the local context, A is 5, B is 2, because those are the values I just passed in. And I can, let's say, jump over, and now go back into my line of execution and step through, figure out bugs this way. So this is insanely useful, having quick ways to set things to watch for, having quick ways to explore, expand arrays, see what different characters are and so on, set breakpoints visually, and just be able to quickly jump between tabs, scroll through all your code. So I really like this feature of VS Code and this extension. One last thing that I'll mention, so let's stop debugging for now. There was no problem with my program. Let's say now that we want to realize that, okay, we're covering the case where we have to enter two numbers, but we're not covering this case. What if one of these functions has a bug? Well, we can test that case, but to do so, we need to create a configuration that will let us pass in some arguments to this command that we're calling to run the file. So the arguments that we can pass in, well, we just need two numbers. So let's just say we're passing in 20 and 10. So just these two numbers are going to be passed in. So what's going to be called is, I'm just going to paste this in the console. So we're going to have that program 20 and 10. So just like if we were to enter this in the console, we would get some output. Makefile.launch configurations is letting us create a configuration in the Makefile tool, the extension, so that when we hit the debug button, then we can pass in the arguments we desire, and do so automatically. We can set it and forget it, so to speak. Now, just one thing before we can use this configuration, we have to actually choose, here's the configuration we have. we can add different names to these things. So that's why we have to choose, what we have. Right now, it's just default because we haven't set a name. But, whatever, pick whatever you have. And then when we launch our target, we should now have two options. So either we do main.exe or main.exe 20 and then 10, because those are the args we set in. So I'm going to choose this one. And we can, always change back later if we want. But for now, we're going to go with this. Again, all of this is in .vscode settings.json so that you can set it and forget it. Make sure everything is automated. And now if we go to Makefile Tools and, start debugging, let's put a breakpoint there. And now you can see the code has stopped here. And Args is now 3 because we actually did pass in 2 arguments. We can go into argv and see, here's the first value of argv. Let's look at the other values. So argv at 1, that is 20. Argv at 2, that is 10. So we can run through and you can now see, it's converting things, it's setting variables, etc., etc. And we can click on this continue button to just run until completion, and we see everything was right, everything was done, and that is it. So highly recommend this tool. Check the GitHub link in the description so that you can experiment with it yourself, and I hope it speeds up many countless hours of debugging as you try to debug nightmarish projects like this.